Friends, welcome back to the second video of interview lecture series. As we have started from the transformer, in the last video we have seen what will happen in our power system if there will be no transformer. So in this video, before looking to the next question, our expert Ranjini ma'am giving some tips when you are preparing for any interviews. So what she is saying is, whenever you are preparing any questions, before going for interview, you have to practice loudly. You have to repeatedly ask that question yourself. When you are preparing for interview, you will be coming up with so many questions. So whatever the questions that you are preparing, after getting the complete idea of different questions of different machines or different subjects, you will have to recollect in your brain and try to explain it in a clear cut way and exactly precisely this is the answer for this type of question. Like that, you will have to practice so that your confidence will boost, will increase day by day. So finally, when you are appearing for interview without any hesitations or fear, with lots of confidence, you will be able to explain the exact answer for the questions the interviewer asking to you. Now let us deep into the question. So again we are taking here one of our most favorite interviewer, Priya ma'am. She is asking another question in our transformer, that is, what will happen if we introduce a small air gap in our transformer core? We all know our transformer core is made up of ferromagnetic material. Now what she is asking, let us take a ferromagnetic material and let us cut a small portion and introduce the air gap. What will happen? Now here our interviewer is asking this question and Ravi is appearing in this interview, and what he will think. Now you imagine that you are Ravi and you are sitting there and ma'am Priya is asking this question to you. How will you give the answer for this question? The first thing what will happen, you will be thinking, when the moment she is talking about transformer, you will be immediately started thinking about, yes, we know how a transformer will looks like, that you are seeing on the screen also. Now what she is saying, you take the same transformer and Ravi is keep thinking, okay, then you have to introduce a small air gap according to ma'am's suggestion. Now take the transformer, see there, after introducing the air gap, this is how our transformer will looks like. Now as a Ravi, when you are thinking this question, how will you answer? Let us see. First we will take the transformer here without introduction of air core. Now see there, this is the case number 2 where the air has been introduced. A small portion of the transformer core has been removed and we have introduced a small air gap. Now the question is, usually before introduction of this air gap, how our transformer will behave? This is case number 1. In our transformer without air gap, usually what will happen, we will be giving a supply voltage. Then the supply voltage will supply required amount of magnetizing current. This magnetizing current will set up the rated flux that is demanded by our ferromagnetic material. And we all know why we are going ahead with the ferromagnetic material. The thing is, ferromagnetic material is having very low value of reluctance. Reluctance and flux are always reciprocal to each other. In any case, here when we are designing a transformer, our agenda is we will have to transfer our flux effectively from primary side to secondary side without any leakage. If I am producing 10,000 flux lines on the primary side, all these 10,000 flux lines I am expecting to get transferred to the secondary side. At least out of this 10,000, maximum line should get transferred with a very less amount of leakage. That is possible with our ferromagnetic material. That's why we are going ahead with the ferromagnetic material. So the reluctance offered by the ferromagnetic material is very low. Now assume the transformer has been set up with the rated voltage, and what you will be thinking, okay, I have a transformer and it has been connected with the rated voltage and it is supplying required magnetizing current to set up the rated flux. Now this is the case number 1. Now ma'am Priya asking you to introduce a small air gap here. Now she is asking, tell me what will happen. What will you think when the moment you are introducing a small air gap? Initially we are having ferromagnetic core, along with that we are introducing a small air gap here. When the moment we are introducing the air gap, what will happen? This air gap will also introduce some additional reluctance. We know reluctance offered by the ferromagnetic material is very very less, but what about air? Air reluctance is very very high. Reluctance is kind of resistance. We have studied in electrical conductor, if resistance is more, then current will be low. In the similar fashion, in magnetic material, if reluctance is more, then magnetic flux will be less. So in air, this is the scenario. Since the reluctance offered by the air is very very large, because of that reason, what will happen? This will oppose the flow of flux in the air gap. So what will happen? Due to the small air gap introduction in the ferromagnetic material, the reluctance offered by the ferromagnetic material plus more value of reluctance offered by the air gap will get introduced. So the overall reluctance has been increased now. Due to the increment in this reluctance, what will happen now? That is the question. So case number 1, we very well know without air gap what will happen. Case number 2, after the introduction of the air gap, overall reluctance is increased. Now immediately we should think, as we very well know, flux and reluctance both are reciprocal to each other. As we are increasing the reluctance offered by the transformer by introducing the air gap, the flux traveled into the transformer will decrease. Now what your transformer will do is the question. Immediately you should think, as we very well know, transformer is a constant flux device. Transformer will always tries to maintain the same flux. As we know, the example what we have taken here is, let us assume the rated number of flux lines that is traveling into the transformer is 10,000. Before introducing the air gap, the transformer was carrying 10,000 flux line. Now after introducing the air gap, due to the additional introduction of this reluctance, let us assume the flux lines has been drastically reduced from 10,000 to 7,000. Totally 3,000 lines are reduced due to the introduction of large reluctance. Why it happened? Because we introduced the air gap. Now, as the transformer is called a constant flux device, what it will do, sir? It will again try to bring back the original flux line. For that, what it will do? In order to increase the more flux, it will go back. Again, it will take more amount of magnetizing current. As we know, as we keep increasing the magnetizing current, flux lines also will increase. So, in order to bring back the original number of magnetic flux lines, it will take more amount of magnetizing current from the supply. This is what will happen. So when the interviewer is asking to you as a Ravi, you will have to explain this way, you will have to demonstrate. So at the end, what you can conclude is, okay sir, this is what will happen whenever I am considering a transformer. If you are introducing the air gap, this is what would have happened to my transformer. So now the question is coming to the next question. Ma'am will be asking, okay, now tell me, what is the basic difference between the air core and ferromagnetic material? Suppose if a material is completely having only air and the another material is having ferromagnetic material, what will have happened? What would have happened? How will you demonstrate the difference between these two materials? That is the next question. She already asked one question, you have clearly explained it. After the introduction of air gap, this is what would have happened. Now she is again asking, okay, let us assume there is one transformer. In the transformer, there is no ferromagnetic material. I have designed this transformer just with the help of core, air core. Here we are having only air core. Now you will tell what will happen. You have to clearly explain that if there will be no ferromagnetic material or something, if you are having only air, what is the basic difference? The thing is, when the moment we are designing any transformer with the help of a ferromagnetic material, the material is having certain boundary, it is having certain limit. It means this material may be having a maximum limitage of, it can carry, let us say this ferromagnetic material can carry 10,000 flux lines. Then this line is called saturation point. As you can observe in the graph here for this ferromagnetic material, if you keep increasing the current, magnetizing current, what will happen? The flux will started increasing into the transformer. When the moment it is trying to getting close to 10,000, that point is called saturation point. It means the ferromagnetic material is achieving its maximum boundary. It is like if you have a bowl or a glass and you are trying to fill it by water. What will happen? You can fill it only up to its top point. Can you fill it further? No. Once the water is filled into this bowl, you cannot pour the water further. This is called a saturation point. In the same way, ferromagnetic material having certain limit, it can carry 10,000 lines. It means it will carry only up to that. You cannot increase beyond this. So that point is called basically saturation point. Now the conclusion is, sir, there is no such a boundary for our air. As you keep increasing the value of current, the flux also will be always increasing. When the moment we are introducing the air gap, the saturation point will go down. It means the transformer further will take some more point. Means initially, suppose if a transformer is saturated here, after the introduction of air gap, transformer might have been saturated to some other point. It will carry further more flux lines because now we are not only having ferromagnetic material, we have also introduced some air gap. So the flux curve will be shifted. That demonstration you will have to demonstrate when ma'am is asking to you. As a Ravi, you will have to explain like this. Okay, ma'am, if I'm having only ferromagnetic material, the graph will be like this. If I'm introducing some air gap, the graph will be tilted or shifted like this. If you are having only purely air based transformer, then there will be no saturation. It will always increase. As you keep increasing current, flux also will increase. I hope you understood. You got the clear idea. Now, I'm just concluding what are all the points that you have to remember, and I will also give some additional boosted point. What is the additional boosted point that I am going to give? Now, if you observe on the screen, I have written here the statement is called flux should be remain same. Where? In transformer. We are trying to maintain the fluxes remain same. So the question number 1, when the moment we are introducing the air gap, what happened? When the moment we are introducing the air gap, reluctance changed or not? Yes. What will happen? Reluctance has been increased. Yes, the overall reluctance increased. Second thing, followed by due to the increment in the reluctance, flux has been reduced. Now, in order to bring back the original flux, what happens, sir? What would have happened? The magnetizing current would have been increased, so that more magnetizing current, transformer will be taking more magnetizing current to bring back the original flux. That is nice. Yes. The next thing is here another point what will happen. Okay, sir, this is the conclusion. Transformer is taking more magnetizing current. Again, it brought back the original flux value. That is what would have happened. Now the question is, suppose if I am further increasing the air gap. Now you tell me what will happen. Further, if you are increasing the air gap, same things will continue. Yes or no? Yes. So again I am increasing the air gap. Again reluctance will increase. Again flux will goes down. Again magnetizing current will increase. But again, the magnetizing current we are taking through the coil. There is a copper coil in our transformer. Yes, from the copper coil current is coming, then it is entering into the magnetic material. Now what will happen? This coil is having certain boundary or not? Yes, it has a certain limit. You cannot generate more and more magnetizing current. There will be a limit. If you try to go beyond that, what will happen? The material properties will get degraded. Yes or no? Yes. So there will be a certain limit. If your material is made up of, we are having copper, we are having ferromagnetic material. If you are introducing a small air gap, that is okay. Saturation point will get shifted because as we are increasing the reluctance, we are introducing more air gap, more flux lines can flow. Instead of initially we were considering 10,000, now due to the introduction of air gap, there will be a small deviation, so that flux point, saturation point will be slightly shifted. You cannot say there will be a large deviation again. No. There will be a large deviation is not possible, sir, because again we are having ferromagnetic material with the air gap. So ferromagnetic material is having its boundary. You cannot go very large amount of value. A slight shifting will be there, not huge amount. And next thing what we have understood is, you cannot go very huge amount of air gap introduction. If I will keep increasing the value of air gap, it is not at all possible to take more and more magnetizing current. So there will be a limit. After certain time period, what will happen? You cannot take, there will be a limit for the magnetizing current. You have to tell no. I cannot go beyond that. If I am increasing the air gap continuously, then it is not possible for me to generate more and more magnetizing current in order to bring back the original flux. So at the end, it is not possible for us to bring back the original value of the flux. That is the next conclusion. And we have also seen the advantage of this. What is the advantage? Saturation point will get shifted. If I am having purely air core based transformer, then further what will happen? There will be no saturation. If that is the case, now my question is, you have understood the transformer? Yes. And you know how to give the answer for this question what would have been asked. Now my question is, when the air core is having no saturation point, why we are designing the transformer with the ferromagnetic material? I have given the answer already. I have already given the answer. Now my question is there any other possibility in which we can consider air based air? We are designing the core with the help of air. Is it possible to keep such a transformer in our power system? That is my question. You will start thinking for this question what can be the answer. If you know, or if you are finding the correct answer, please post it in the comment box. I hope you got the idea. This is all about this lecture. Let me coming up with another important question or more interesting question in the next video. Thanks for watching our video. If you are really understanding or getting something from our video, don't forget to subscribe our channel and also please forward it to your friends. Thank you all.